First beginnings of electric service in the United States. Thomas Edison's Pearl Street Station, which was the first central electric station generating electricity at one point and distributing it to their customers over a series of distribution lines, was put in service in 1882. That same year, the first companies were organized to generate use of the people of Rock Island, Davenport, and Moline. In 1926, at the dedication of the Riverside plant, a booklet was published giving 40 years of the development of electric service in the Quad City area. I'm going to use it and give you a few background of electric service in the Quad City area. On May 1st, 1882, the Davenport Electric Light Company was organized, and July 14th year, the Rock Island County Brush Electric Light Company was organized. On November 25th, 1882, the Merchants Electric Light Company of Moline was organized. These companies organized primarily to use electricity for street lighting, for electric railways, and for some commercial use in lighting stores. First plant in Rock Island was used for street lighting. 11 towers, 125 feet high, were set up in downtown Rock Island and used for generating street lighting. In February 9th of 1884, S.S. Davis and T.B. Davis took over the Merchants Electric Light Company of Moline and installed a 50-light arc machine. This was one of the largest in the country at that time. In 1884, the Davis brothers organized the Merchant Electric Light Company of Rock Island and built a plant on 19th Street from which stores in Rock Island were lighted. On November 4th, 1885, there appears a resolution by the City Council of Davenport to light the city with electricity. The next really impetus to electric use were streetcars. On August 11th, 1888, electric streetcars were tested on the Brady Street Hill. Cars loaded with 40 or 50 persons easily climbed the hill, and there was general rejoicing. This was probably the second electric streetcar line built in the United States at this time. In the period from 1882 to 1888, there were many small companies formed, developed, or combined in one another to use electricity for street lighting and electric railway systems. In the latter part of this period, the companies were organized that later became the cornerstones of our present company. In 1888, the People's Light Company of Davenport was organized. 1894, People's Power Company of Moline. 1906, Fort Dodge Gas and Electric Company. And 1909, the Iowa City Gas and Electric Company. These early companies the first company used reciprocating engines to generate the electricity and also used water power. In the power plant at Moline, which was one of the first water power plants built in this area, a number of devices were tried for transmitting the power from the water wheels to the electric generator, or dynamos as they were called. Shafts and gears were used without success, and a long rope drive finally proved successful, although in one trial pulled out the whole side of the plant building, almost completely wrecking the plant. So they had problems in those days too. Another thing that was developed here in this area and was one of the first in the United States was the interconnection of separate power plants. So this would cover the period about 1882 to 1909. There are several companies, other companies that combined the electric companies, but in general these were the major ones. The next major development in the company organization came in the period 1912 to 1913, when the United Light and Railway Company was set up as a holding company and used to buy the stock of the individual companies and operated them. This company existed until the middle of the 1930s, when the Securities Exchange Holding Company Act of 1935 required companies such as this to be broken up and the individual companies allowed to combine and own their own stock. At this time, in 1942, Iowa-Illinois Gas and Electric Company was organized from 10 of the companies formerly held by the United Light and Railway Company. The next major step in our company's organization, of course, will come with the formation of Iowa Energy at some future date. Before we continue to expand the electric system development further, let's take a look at some of the photographs of the facilities used during these early days. One thing that you'll note in looking through some of these pictures is how much of the equipment is still in use today. Even though the pictures show equipment that was installed in some cases in the early 1900s, 1910s, and 1920s, you'll recognize a lot of the equipment today. This picture showing the Sears water power plant, one of the first that was built in this area, is practically unchanged today. This plant is no longer in service. Some of these pictures here of the Moline plant could be used today with very little changes. This plant picture here showing some of the construction of the additions to the plant should be very familiar to a lot of people. This shows some of the turbines at Moline plant, and some of them are still in service today, put in the early 1900s. Another view of the turbines in the Moline plant area. Here's a view of some of the bus work, the open bus work, the equipment that was installed in the 1910s and 1920s. This equipment has just been removed this year. This transmission line going from Sears water power plant to Davenport was taken down some time ago, but the design is such that it would not appear out of date today. In the early days, many of the electric systems were tied in very closely with gas properties, and we'll see them in many areas there. This view of the substation, interior of the substation at Rock Island, 23rd Street substation. Much of the general area is very familiar, but you can see the brick cubicles used for their bus work, the rotary engines for generation of power. The outside of the building here shows one of the gas holders. In the early days of natural gas, there was no natural gas. The gas was manufactured and stored in these large gas holders. So all of our older subs, Substation G in Davenport, E in East Moline, Rock Island, Moline plant, all had the large gas holders for the storage of manufactured gas. But the general shape of the building here has been the same for at least 70 or 80 years. Now we'll take a quick look at some of our other properties. this view of the Fort Dodge generating station. This was built in the early 1920s and was just taken out of service recently. The Iowa City electric plant. This building is still in existence today, although it is not the present electric generating station. Now let's take a look at the development of our electric system in the different districts. First requirement for an electric system is, of course, some means to generate electricity. The early generating plants in this area were powered either by water power, by dams built across the parts of the Mississippi and Rock River, or by reciprocating engines driving electric generators, or dynamos as they were called. The first plants in our company system were small water power plants at Moline, at Sears, and at Coralville in Iowa City. At the Moline generating station, which is the oldest plant site in the Quad City area, there have been more or less continuous electric generating stations of one type or another since 1888. At Moline, the first steam turbine in this area was installed in about the 1913 period. Moline has been expanded several times since then, the last time being the addition of gas turbines that were put in service in 1970. So at the present time, Moline has an installed generating capability 179,831 kilowatts. The next plants, in terms of time of construction, were the ones in Fort Dodge and the one in Fort Dodge. This plant site, after some small water power plants and reciprocating engine plants, was started in 1923. This was expanded several times over the period, but by the 1960s, its small size, had prevented it from economic operation, and it was phased out in about 1968. However, that was the next in terms of installation. The Coralville site was started in 1923 also. This had a small water power plant on the river at Iowa City. The steam turbines were installed, first ones being in the 1930s. The older plant section, the steam turbine and water power plant, followed the same pattern as Fort Dodge and were phased out at the end of 1968. However, at that same time, construction was started for a gas turbine installation, which was completed and put in service this year. So Coralville is our Iowa City generation, and it has a capability now of 70,840 kilowatts. Our largest generating site, Riverside, was started in 1925. It has been expanded at least 5 times since then, the last being in 1968 with the addition of a gas turbine power block there. Riverside, being the largest one, has capability 345,291 kilowatts. As a result of a flood in the Fort Dodge area in 1947, a small capacity gas turbine, a small capacity diesel engine operating a generator was installed first at the Fort Dodge plant site and then later moved to Manson, used as a emergency source up there. However, that is still operational, and at our peak periods, that is used as the means to determine when we have all of our equipment on the line. When the Manson diesel's on the line, we're right down to the end of our generating capability within our own company. That was purchased in 1948 and has a capability of 995 kilowatts. Once each year, all of our generating plants are required by Iowa pool agreements to demonstrate their 4-hour capability. So each year they crank up each of the generating plants to their maximum capacity, and this figure is used as a measure of their maximum capability. So these are the units that our company presently has in service. If we add all these up, we'll find that we currently have a 4-hour capability of 596,957 kilowatts. Within the next 2 years, this would be expanded to a great extent with the completion and putting in service of the 2 units that we are building in conjunction with Commonwealth Edison Company of Chicago. In 1971, it's currently planned that Quad Cities unit number 1 would be in service, and this would have a capability of 200,000 kilowatts to our company. The total unit size is 800,000. However, our company would purchase 25% of this. In 1972, Quad Cities number 2 will go in service. So you can see within a relatively short period of time, our company's total generating capability will be approaching 1 million kilowatts. Now let's see how the electric transmission and distribution system developed to distribute this electricity to the customers. As we mentioned, the earliest sites for generating plants and what would correspond to substations in the early areas were at Moline, where we had our first generating plants, at Sub-R and Rock Island, Sears Water Power Plant, these were the first ones. Then as the years went on, in the early 1900s, these plants and other substations were built. The plants were interconnected with 13,000 volt lines that would correspond to transmission. We had lines going from R to P, P to a substation in East Moline, R to S, substation G in Davenport, substation T in Davenport. So we can see we had quite a series of interconnected lines. These are 13 kV lines used as transmission. In each of these substation sites, then we had 2400 volt and 4800 volt two-phase lines that would extend throughout the commercial, residential areas to serve the industry and the people in that area. At each of these sites, we'd have distribution lines extending out into the country and also to the downtown area. Now this system, this distribution system, worked surprisingly well for quite a long time. The next major development in the Quad City area here was, of course, the construction of Riverside Plant. And with the Riverside Plant, this was tied in by 13,000 volt lines to Substation T in Davenport, and through some submarine cables underneath the Mississippi River to East Moline. At the same time, in order to provide a heavy-duty transmission capability between Riverside and Moline Station, we built the double-circuit 69,000 volt line from Riverside to Moline, which at the time of construction was the second highest capacity in the western part of the United States. This was kind of our backbone transmission line, if you want to call it that, and that was built in 1926. This system with 13 kV transmission lines with a 69 kV backbone line between Riverside and Moline plant, and with 2400 volt and 4800 volt distribution, works surprisingly well up into the middle and later 30s. In the later 30s, we started in on and developed a new type of primary distribution system to provide greater reliability of electric service in this area. It's called a 4 kV primary network system. This is a typical or general description of the distribution system. Each substation consisted of a transformer from 13,000 volt to 4160 volt, three-phase, four-wire, and a series of tie line feeders extending from each substation to every other substation. The 13 kV lines feeding the transformers were from separate substations as much as possible, from separate bus sections in a given substation. The substation that we installed here, called unit substations, used air circuit breakers. We were among the first utilities in the country to use air circuit breakers both at 4 kV and 13 kV to any great extent. So you can see that from these tie lines we would have circuits going down the alleys and down the streets to feed the residential customers. And since from a transmission standpoint the different sources would feed the given substations, the transformers themselves were sized so that you could take any one of the transformers out for maintenance or because of equipment failure, and the tie lines to the adjacent substations would provide enough capability to feed the load from this substation. On a given circuit you would have two means of feeding each major load area. So this was a system that provided a great deal of reliability to electric service. This primary network system was started in the Quad City area in the late 30s and early 40s. It was started in Fort Dodge and Iowa City in the period after World War II and is continuing in a confined area today. The next system to be expanded in the Quad City area was an increase in the transmission capability to provide the means to get the generating capacity to the load that was growing up in the outlying area. So this was the development of the Quad City 69 kV loop system. Now I think we want to take a little break at this particular time while we get some additional material here. As you will recall from our previous page, the 69 kV transmission system for almost 15 years consisted of our double circuit 69 kV line from Riverside to Moline plant. This sufficed to transmit the electricity from Riverside to Moline plant and to allow for taking units, generating units out of service at either plant for maintenance for quite a few years. The next expanded step in our 69 kV system was the construction in 1942 of a transmission line from Riverside around the north side of the Quad Cities to Substation G in Davenport. This was initially built in 1942 with one circuit. However, it was built with capability for adding a second circuit, which was added in 1951. In 1953 and 54, a double circuit 69 kV line was built from Moline plant to Sub-R. And then in the, as you recall down here, we had a Substation S. Because of other requirements, which we'll mention at a later date, the expansion and development of our 161 kV system, a Substation 18 was built at the southwest edge of Milan and Rock Island. And in the 1956-57 period, 69 kV lines were built from Sub-R and Rock Island to Sub-S, from Sub-S to 18, and then from Sub-18 to Sub-G. These were built in the 1957 period. So you can see at this particular point in time, we have completed our first 69 kV loop, that is a continuous 69 kV transmission path interconnecting major substations in the Quad Cities. This was built in 1954. This allowed us to feed our major substations from two different directions and allowing much greater reliability for service, and set the stage for the next type of distribution system to be developed in the 1957-58 period. This was the establishment of a 13-8 7960 grounded Y type of distribution system. The distribution transformers and circuits are sometimes called 13-2/7620 system, but basically what they mean is you have a distribution line, 3 phase wires and 1 neutral. This allows you to buy distribution transformers and construction at a reduced cost and transmit to the customers electricity a little bit more, a little less expense, and in some cases allow you to expand the area that you're served. This 7620Y system, as we call, is being installed in all of our suburban areas, in the Quad Cities first, starting in about 1958, and in Iowa City and Fort Dodge at later dates and time. A typical substation of the 7620 system is fed by two 69 kV lines. Each 69 kV line has a circuit breaker on it. We go through a 69 kV structure. The electricity is transmitted, stepped down on a transformer. Standard size is about 20 MVA, which can be expanded to 26 MVA by addition of forced cooling fans, and in later ones expanded to 33 MVA. The secondary side of this transformer is connected to 15 kV metal-clad switchgear to 2 bus sections, and from these sections we have radial feeders extending out into the suburban area. Since we have a single transformer, if we were to lose this transformer, if we wanted to take it out for maintenance, unless special provisions were made, we'd be kind of out of luck. So starting in 1958, we purchased a complete mobile substation. Our first one had a capacity of 12,000 kVA, and in a given substation we have provisions for connecting the 69 kV side of the mobile substation to a 69 kV line. The 13 kV side is connected to the 13 kV bus. This allows us to completely bypass the entire 69 kV structure and the transformer to allow maintenance or construction in these areas. As you can see, what our typical pattern of construction would be if we have a 69 kV line running past the substation site. We would break into it, open it up, bring each line into the 69 kV substation structure, and then continue on. This allows us a two-way feed to this transformer. As the load increases in a specific area, we need more feeders out here. We can put in a second transformer here. At this particular time, we'd probably also put in a 69 kV circuit breaker for still greater reliability, and that we could isolate either bus section, and we would put in a bus tie circuit breaker on the 13 kV side and probably more feeders out. So they're currently designed for 6 to 8 feeders from each substation. Well, with the advent of this type of substation, our 69 kV loop system was expanded to a great extent. Our first of the new 13.2 7620 subs in the Quad City area was Substation 58 in northern Davenport, in which we broke into one of the circuits on our transmission line here and brought it into this particular sub area. Now, during the period here, we expanded the loop system around the southern part of the Quad City area through a series of substations that were later tapped into our 69 kV loop. If we get this 69 kV line in there, we can see that we now have this line here is opened up there. So now we have a dual feed to Substation 58. This was put in service in about 1958. The next major step was as I mentioned, the construction of the southern end of this 69 kV loop around the Quad Cities. The 69 kV line was built from Sub S to Substation 22, which is in the southern part of Moline. This was completed in about the 1966 period. Finally. Next, lines were expanded from Substation 22 over to Substation East Moline, Substation 37, and then finally on to Substation E. This also is in the 1966 period. Now, previous to this time, in about 1955, a line was built from Moline Plant to Substation E, and when the last large steam unit was built at Riverside, an overhead line was built from Riverside to WNO East Moline. This was a double circuit line. The first one was put in service in 1964, and the second line in 1968. So you can see we have several loops around the Quad Cities. This line here completed the southern loop. This completed another loop there. With the completion of this loop and the expansion of our load this year, last year and this year, 2 more subs were built in southern Rock Island and Moline. Sub 36 in Moline, sub 38 Rock Island. Transmission line was built up to sub 38 over to sub 36. And coming back to our major transmission line. At each of these subs we built the type of type of distribution sub that I had previously shown. This line is open at this point, so we have a complete loop system around the Quad Cities. We also have a loop out to a new sub that's being built to sub 39, and then a transmission line from 37 to 39. So you can see we're having a continuing series of loops built throughout the Quad Cities to allow two ways to feed each of the individual substations. This system is being expanded in Iowa also. Substation 56, west edge of Davenport, was originally built as a 161 kV transmission switching station, but has been expanded through construction of several lines. In the 1967 period, line was built from sub 56 to sub 75, and then back to sub G. In over a period of years, substation was built in northwest Davenport, Substation 59. It was put initially in 1963 from a section of the line tapped to one of these. In the 1970 period, this line was tapped by two lines from sub 56. So we have a continuing series of loops. The next type of loop in sub 40 was built in 1970 also. Sub 72 in Bettendorf is currently under construction. We had a temporary sub at this site, which is tied into our transmission line from Riverside to 58. This sub will be expanded in 1971 and tied in by the second line up at this point here. So our pattern of expansion seems fairly evident now. The 69 kV transmission system that was initially used to transmit electricity from one major substation to another is now more or less a type of distribution line, or at least a sub-transmission line being used to distribute electricity to distribution subs. And the major bulk transmission of energy has started at 161,000 volt. A 161,000 volt system originated in the Quad Cities at Riverside in the late 1940s as a part of a grid system that was developed in Iowa and throughout the Midwest. A 161 kV transmission line was built from Riverside to Hills Substation south of Iowa City. There it extended on to Des Moines, branching off in Des Moines, one leg going north to Fort Dodge, the other leg going southwest generally to Kansas City. The next stage in the development of the 161 kV system, incidentally, was built in 1948, was the putting in service of Substation 18. This allowed us to build 161 kV lines to interconnect with Illinois Power at Galesburg. In 1956, and with Union Electric Company near Burlington in 1961. Just previous to this last edition here, transmission line was built from sub 18 to a point in northwest Davenport where a switching station was called sub 56, which has since become a major transmission substation. And this was put in service at the end of 1960, the first part of 1961. So we can see the beginning of a loop system development here. The next stage in this loop system was the building of a transmission line from sub 18 around to a substation near Barstow called sub 39, and then extending through this substation site to a substation further up river near Cordova, sub 17, and from here then we interconnect with interstate power. At the same time, from substation 39, a line was built towards Silvis, where at substation 48 we have a transmission substation and also some distribution to serve the new John Deere foundry there. And then finally a line completed from substation 48 to Riverside, thus completed a 161 kV loop around the Quad Cities. And at our major substations here, then we can make interconnections to other utilities and allow room for expanding into the next stage of development, which we'll talk about in a minute. But we can see here the pattern of expansion. It's very conceivable. These lines were built in 1968, incidentally. And this line in 1967. But we can see that the next stage of development of this system is the installation of substations at various points along these transmission lines and stepping down from 161,000 volt to 13,800 volt for use in serving the load in that particular area. We have a continual period of developing a loop system, breaking up the loops to serve individual substations, and then overlaying the given transmission system with one of a higher voltage. So logically, the next stage in this development is a 345,000 volt system. This voltage was introduced in the Midwest in the 1966 period when a line was built basically from St. Louis on the south to Hills Substation just south of Iowa City, and then extending north to the Minneapolis-St. Paul area. At the time of construction of these lines, the two individual line sections were the longest 345 kV lines in the country, and they have since then been broken up by other subs at this along their length. In the intervening years since 1966, these lines have been expanded by development of other lines to form 345 kV loops. Just previous to the time the Hills line was in service, the line was built from Minneapolis to Milwaukee. Lines had been built then from Milwaukee to the Chicago area, and then from the Chicago area extending towards the Quad City area, with their goal being the Quad City Station. And these have been tied in the first part of 1970. At the same time, lines were built from Hills to the the Quad City area. Sub 56 is where they initially terminate, and the line extends from sub 56 to the Quad Cities plant. From the Quad Cities, we come down here to sub 39. And at each of these points here, we have a step-down transformer from 345,000 to 161,000 volts. You can easily see the development of the next stage of our transmission system, loop from sub 39, extending in some manner basically around to sub 56, or to another plant downriver and then back to Hills. There are several possibilities for expansion of the loop system then. There again, with the aim of providing greater reliability to the major load centers from a dual feed. From Hills, a line has been built to the Des Moines area at 345. From Des Moines to the nuclear station that they're involved in, Cooper Station, which again is tied back to the Kansas City area, and then from Kansas City to St. Louis. Extending north, we have a line built from Cooper through the Omaha area to Sioux City, and then from Sioux City extending northward and eastward with several other substations and here back to the Minneapolis area. From both of these points, lines extend further to the east and west. So this is a part of the overall plan of developing a continual loop system. Future plans in the Iowa area in the late 1970s or early 1980s are bound to include a 345 kV line across basically the northern one-third of the state. This kind of gives you a background of the electric transmission and system and distribution systems in this area at the present time. On a functional basis, there are about 3 or 4 different types of substations. The generating station substation obviously has different requirements from some of the others, in that it should operate continuously at a high load factor. We have at the present time 3 generating station substations: Riverside, Moline, and Coralville. Transmission substation is a type of substation that is used to primarily switch electricity at the higher voltages, 161,000 volts and 345,000 volts. And quite often a distribution or sub-transmission substation is included there. We have 9 subs that might be classified as this. Sub-transmission allows distribution at a lower voltage, with about 5 in that category. The distribution sub is kind of the basic sub from where individual customers are served. In the unit type substation, the 4 kV primary substation, we have a total of about 49 in this category, 37 being in the Quad Cities and 6 each in Iowa City and Fort Dodge. The 13-2-7620 4-wire substation, we have around 17, 12 in the Quad Cities, 3 in Iowa City and 2 in Fort Dodge. Now let's take a short break here while we obtain some more material. The next part of this presentation I'd like to use to cover the means of identifying our substations and our transmission and distribution lines. Going back to a previous slide, you may recall we had substations scattered throughout the Quad Cities. In the early days of our company, each substation was identified primarily by its physical location. It's very easily to identify sub R as Rock Island, and the letters were usually not used in the early days. They're just the physical identification. Sub R would be Rock Island, sub T 3rd Street, sub G the gas plant, sub S Sears, sub E East Moline, sub P Moline plant. With the development and expansion of the electric system, it was obvious that this system was going to run into trouble. We'd run out of letters for one thing, and we could quite often have subs with no means of really giving them a unique geographical location. So with the completion and putting in service of Riverside, we started assigning the substations in alphabetical order with no relationship to their physical location. Sub A being Riverside. And we went through the alphabet using up all the letters down to Z. And then we arrive at the problem, what we do from there on. So the scheme that has been developed was to assign the numbers from 10 to 49 to Illinois subs, and then 50 through 99 to Iowa subs. This scheme has worked fairly well. we're kind of arriving at a point in the Illinois subs where we've gone through all the numbers up to sub 48. So you can see we're going to have to develop a new system or an expansion of this system in the near future. Now, the identification of a particular distribution or transmission line is composed of a series of 3 to 4 digits. The first digit or digits is the voltage level. And of course the voltages we would be using would be 4 kV, 13, 66, 161, or 345. The next two digits are, next one or two digits or letters or combination of digits letters are the terminal points of the given line. That is a point at which a circuit breaker is located. In one case we have the, I want to call it the origination and the, well, this is not a good word either because we have a certain pattern in describing the line, which I'll go into in a minute. But the next two digits then are going to be the two ends of a given circuit. And the last digit then refers to the number of lines between the same 2 points. Now, going back to the identification of the distribution line following the voltage level, the next point, if we have a radial feeder, would just be the substation number. An example of this might be circuit 4R-1. In this case, R would be the origination of this particular line. There would not be a substation at the other end, so it would be a radial feeder, and there would be just one circuit between one radial feeder. Now, there could be, as you could readily imagine, several radial feeders, so these would be numbered in consecutive order. Now, if we have a line that goes between two lettered substations, the letters are arranged in alphabetical order. That is, we would have a substation 13 kV line from sub A to sub T. This would be AT. This would be 1 or 2, and so forth. If we have a line between a numbered sub and a lettered sub, the number is given first. As for instance, we would have a line, let's see, between, say, sub 56 and sub G. That would be circuit 66, 56, G, 1. If we have a line between two numbered subs, in general they're placed in numerical order. Say we had a 13 kV line between from subs 20 to sub 22. That would be 20, 22, 1. We use the hyphens to distinguish between the voltage level and the substation, and between numbered subs, and between numbered subs and the number of lines between a given 2 points. Hyphen is not used between two lettered subs. Now let's show a few examples of this. Our first example was a radial feeder, 4R1. Another example might be a radial feeder from sub 40. That would be 1340-3. This would be the third radial feeder from sub 40. Now, if we have a 13 kV line between subs A and T, the 13AT1. We can also expand the substation identification in case we have a 3-terminal line, which happens with some regularity on our 4 kV circuits. Let's see if I can think of a good example. Well, I'll make one up. Say 4, 20, 22, M1. This would be a 3-terminal line with circuit breakers at subs 20, sub 22, and some ebb. We do not use a substation terminology unless there's a circuit breaker at that point. Now, on our transmission system, we could have a 161 1856-1. So we use the same system, the same sequence of digits, the same meaning of the digits at all voltage levels. This system will be expanded in the future and will probably be modified with not only the expansion of our company, but with the coordination of our electric systems into those of Iowa Power and Light, for instance, if we were to complete the merger with Iowa Power and Light. But this is something that would be worked out in the system. That concludes this particular presentation.